telescopes, especially younger folks making telescopes. So the challenge is, I mean, for all of you who have made glass, it takes many hours to make your mirror, and it's not cheap, right? To make it, and then even to get things coated. I mean, you used to be able to get a mirror coated for 25 or 30 bucks. Now it's like 100 plus to get any kind of coating on a mirror. So that's a challenge. That's one of the ATM classes that I ran at the college that I taught at for many years. So that's a great accomplishment to go make a mirror, right? But now you have to make it into a telescope, and so it's very expensive to go make your telescope. That's one of the telescopes from last year up on the hill. There's a secondary mirror holder, there's a focuser, there's a finder and a finder bracket, and there's a mirror cell. And by the time you buy those, even relatively inexpensive parts, you're talking about a couple $100. So if you're somebody sort of dabbling, trying it out, if you're a high school student, if you're a college student, that's a huge barrier to getting yourself into a telescope. Oops, clicked one too far. There we go. So these are examples of some of the telescopes that my students made. We came up with a very canned system where we used their grinding stands to become pipe mounts, and they had cardboard tubes, and we just made some wooden parts, and we used a little PVC part that we bore out to just have a slide eyepiece holder. And they're okay, and that works, but it would be nice to have something a little bit more durable and a little bit more effective. So 3D printers have become kind of ubiquitous at this point. So this is a Prusa, the one that I have here, but you can buy ones that'll print sort of a 4x4x4 volume for under $100. So pretty inexpensive, and a reel of material is maybe 20 or 25 bucks. So for $100 to $120, you can have the capability to make all sorts of things. Dozens of things out there, and on the right is just a layout of a few of the parts that I've made. And as a matter of fact, my talk, I'm not going to talk to you for an hour, I'm going to talk to you for a few minutes, and then this is a show and tell day. I have a whole bunch of parts and materials up here I want you to come up and actually look at so I can show you what you're able to make and how valuable they are, because I don't think you want to sit here and have me talk at you for an hour. So one of the key things in making parts is you have to be able to draw them up. Okay, there we go. And so you have to learn a little bit of 3D CAD. It's actually really easy. It's not hard to do. And there's a lot of free software out there. So on the left here, on the right is something called FreeCAD. Guess how much it costs? FreeCAD. 3 guesses, first 2 don't count. And basically, this is a collection of primitives. You need to make a box. You click on the thing that looks like a box. You drag it to the size you need. You make something that's a cylinder. If you want it to be a hole, you draw the cylinder and you just subtract it and you make a hole. So you can make pretty much every kind of shape you want. This is a little part for a focuser, for example, that I was working on. Haven't printed that, but you can do things with it. To the upper left is sort of one of the be-all and end-alls. It's Autodesk's Fusion 360, which is a completely total function 3D modeling thing. There's a fee for getting it, but if you're involved in education in any way, if you're a teacher, if you're a student, you're involved with a school, they give it to you for free. So, it's a couple of $1,000 if you go to buy it, but as a college faculty member, I get it for nothing. Now, I don't need to use it. I use FreeCAD to do a lot of things. One thing it has, which by the way, even SolidWorks, which is the super duper platinum standard of 3D modeling things, which is very expensive and hard to get. Fusion actually has native threads. So you can make threaded parts. Believe it or not, SolidWorks does not have native threading, which is mind-boggling to me, that you can't just do that. So you can put native threaded parts on there, so that's very cool. So you can draw these things up, you then take that file, load it into a program that comes with your printer, that then converts it into the code that the printer needs. You take your little SD card out, plug it into the printer, click go, and go take a nap. And when you come back, voila, there are parts. So of the many wonderful things about this is, the material is so cheap and the process is so quick that A, you can make multiples if you're making multiples of something, Like on one of my scopes, I need little lock knobs, and you'll see one of them up here. So I need a dozen of them. Have it make a dozen of them. Very easy to do that. If you make them by hand, you have to make each one at a time. The other thing is it's great for prototyping. In fact, this technology used to be called rapid prototyping. It's so cheap to do. You go, I'll make one, and I'll just print it rough. Yeah, that kind of looks like what I want, but I really want that hole over here. Okay, I'll make another one. Whereas if you're on a lathe and a mill and you're doing this with expensive aluminum, you're not going to sit there and go, I'm just going to whip something up and see if I like it. Well, here you can. So you can do a lot more experimentation, and then even if eventually you are going to machine something up, at least you know that you've got all the nuts and bolts in place there. So let me give you some examples of some things, and again, I have samples of these up here, so I'm going to invite you up in a few minutes to come play with them. But if you want to have like little solar finders or your little laser pointer finders, and you need the alignment thing that takes those 3 pieces, that takes about 20 minutes to print. Total cost, about 12 cents. I think very easy to make something like that. I guess I have to be closer for this to work. There we go. Mirror clips, little clips to hold mirrors in place. Okay, very easy to make things like that. Little red dot finder brackets that have the little dovetail thing on there. I'm going to tell you where these things come from in a second. Those are the mounting plates for the secondary on the Schief Spiegler that I finished the mirrors for 3 years ago that I really need to finish and bring to convention. But again, what you can do is that has a mirror that needs to be tilted at a fixed angle. You can build that tilt right into it. So it's perfectly straight and on axis, where if you were to try to cut that out of wood or something else, it's going to be very hard to make it to fit that well. The little standard Cinta dovetails for all the little things that slide in. You can make those things very easily at next to no cost. And again, I said little lock knobs and things. So, for example, one of the telescopes we have in our outreach program, because I have students doing this, they of course lose things. So a mountain comes back and go, okay, where's the clamping knob for the tripod spreader? I don't know. Okay, what does it take? Quickly draw up a little X, put in a hex to take the nut in there, print the thing out, put it on there, repair part. So it's really good for making repair parts. Now, one of the great resources that you have for this is the fact that once the code has been written, once somebody's drawn something up, anybody can make it anywhere, okay? So if you're looking at this and you're like, gee, I'd like to have one of those little dovetails, you give me your email address, I send you the file, you put it in your printer and you make it. What this means is that there's a huge library out there in the world of stuff. And I was going to do a screen grab and put it in here, but I didn't get to. There's a place called the Thingiverse, Thingi verse, where there's a whole library of stuff. So anybody can put stuff up there. In fact, things I've made, I'm putting up there. So that Cinta dovetail holder at the bottom left and the red dot finder in the upper right, I did not invent those. Those came from Thingiverse. I was just looking up telescope stuff. Hey, what kind of telescope stuff is there? I'm like, ooh, that's kind of cool. Download the file, put it in the printer, boom, part. Okay? And that lets you make all sorts of interesting and different things. All right, let's talk about the economics of some of this for people getting into telescopes. Okay, so you make your telescope. Oh, yeah.
What is the strength of this material?
You can shoot many different, firstly, you can shoot many different just raw plastics. So PLA, which is kind of the one that you start with, is actually quite durable, works very well. I wouldn't want to drive my car over it, but I have PLA parts that are years old that hold up well. The only bad thing about PLA is it's kind of thermally sensitive. You leave it out in the sun, it'll soften. The stuff called PETG, which has a much higher thermal strength, about the same cost. You can print in PETG, you have to have different settings on your printers. You can buy fiber, this material, that's loaded with different reinforcers. You can get carbon fiber material. So you can actually print carbon fiber reinforced, which means you can be printing out, basically carbon fiber parts. There are metal-loaded materials. In fact, John Martin gave me some samples here of some things he made, and you'll come see this, but that has copper in it. It's copper-loaded. So you add tremendous amount of internal strength to things by using a metal-loaded fiber. So, I mean, it's amazing what you can do. There are 3D printers that print in metal. They're $100,000. So you need at least two, right? Yeah, I buy two, they're small. But they actually will shoot metal and make completely finished metal parts right off the deck. That's wicked cool. That's used in industry. The price will come down, but I don't think it's ever going to come down to $89.95, which is what you can spend for a little printer right now. That would be cool. So you've made your telescope and you've decided, okay, I need to put the parts on it, so I'm going to go out and look for a focuser. And these are about as inexpensive as you're going to be able to find. So there's an 1.25" focuser there from Agena, and it's $95. They do make a helical there. Those are actually not bad. I put them on a couple of public scopes, and that's $59. Okay, that's actually quite a bit of change, right? If you're going to buy $95 for just the focuser, we still have to put the other parts on there. What can you do? You can 3D print focusers. Total cost about $1.25 to make those. So on the left is a 2-inch helical, basically functionally equivalent to the one you saw in the prior picture, and a 2-inch 1.25" adapter, very simple to use. The silver one to the right there is an 1.25" helical. You'll see examples of those here. Now, the other thing you can do is, because you can make these parts, they're inexpensive and you can customize them. I had these at one of our mirror classes last year, and Dick Parker was looking at them going like, this is great, I need one of these for one of my clients I'm doing a mirror with. And I said, okay, I'll make one for you, no problem. You just pay me a couple of bucks, I'll send it to you. I said, well, what size is the tube? He goes, well, it's an 8-inch OD tube. So you can quickly modify it, the base plate part that has a 4-inch radius curve on it, boom, fits that tube. Now you're going to see one here that John made where he stuck with the flat one, but then he just made basically a little wedge inside that has the curvature to fit his tubes. You can do it a couple of different ways. You can make adapters, or you could just modify it to suit the tube that you have. And again, if you fit it on the tube and you go, it said 8 inches, it's really 8 1/32, oh darn, you go print another one. Right, the kind of thing that if you machine it up, you'd like, oh my God, I'm gonna have to buy another sheet of aluminum. And yeah, just print another one of those things. Make the change in the software, reprint it, go away for an hour, come back, new focuser base. So that's a really, really great thing. Okay. Really expensive parts are like secondary holders, right? Spiders. Very easy to make. Again, it's just a truncated cylinder. But one of the other great things that you can do, so this is slightly more advanced, you may or may not know this, but when the secondary mirror goes in a Newtonian, it is not centered in the tube. It actually needs to be offset by a little bit to capture all of the light. Most commercial spiders are just centered, and then you have to kind of futz with them, mount the mirror slightly off center and do stuff. Well here, when you print it out, you just print the offset right into it, so that your rod is dead centered in the tube, everything squares up, and the secondary is right where you need it. So if you look up, this was for a 6-inch f4, you can see up in that upper left picture, you notice that rod's not at the center. It's offset by the amount of the drop in there. Total cost to make that part, there's more money spent on the little set screws to do the alignment than there is to make the part. So just unbelievably economical for doing things like that. This is the secondary holder in my 10-inch at home. Everything up there, the part that's holding the mirror, the part that's for alignment, and even the spider hub are all 3D printed. So you'll see the parts for that here. Other great advantages within the telescope, it has almost no thermal mass. So as opposed to having a big heavy aluminum thing that needs to cool off, almost no thermal mass, weighs next to nothing. So if you're making lightweight stuff, that's really great. So there are all sorts of benefits in doing things like that.
Are those spider vanes printed, or are they
No, they're actually 5mm stainless shim stock. And I'm building another 10-inch now. I'm going to use 3mm. By the way, a commercial spider is 20mm. So this is diffracting much less light into a much longer streak. So that really cuts down on the spider diffraction. And then other little things like lens caps. How many of you have ever lost a lens cap? Don't you? Okay. Print one up. or print up an extra and have it there. So on my telescopes, by the way, I make everything. I don't use any commercial parts, so I make my own focusers, I make my own finders. Well, man, it's not going to come with a lens cap. If you make your own finder, poof, lens cap, bingo, ready to go. Then another thing is you can invent little gizmos. So you'll see the eyepiece on my finder. I find it very annoying when my finder dews up at a right angle. The eyepiece is pointing to the sky, it dews up. So that's a little flip-off cap that keeps it from dewing up. Kind of thing, again, that you can, I went through, I think, 6 different versions before I decided I like this one. I'm like, oh, I need this one a little longer, this one a little, and you can just do that. So that's a very cool thing to do. So that's an example of what you can do there. Electronics and motors. I added, there's a declination slow motion on the telescope, so little gear motor that went on there. Well, how am I going to mount that up? Got a 3D printer. That's easy. You have the bolt pattern, put some holes in there. Actually, where the spindle comes through, actually goes through a little sleeve so that I strain relieve the motor. Took me, I printed 3 of them. One, made a little modification, printed one, and then I printed an extra one for a spare just in case. And there it is, all set up there. Electronics boxes.
How long did it take you to design the motor mount? How long did it take to design the motor mount? Do the 3D graphics?
About 20 minutes. Because, I mean, realistically, you go into FreeCAD. I'll just go through. Go into the FreeCAD. Okay, I need a plate that's about this wide by about that long. Click on box, give it the dimensions, boom, there's the plate. Okay, let's see. I need a hole in the middle. I've measured the size of the shaft. Go to the middle, click on the cylinder thing, click there. It asks you how big the diameter is. You put that in there, and then I go to a thing that says subtract this out so it becomes a hole. And then you do the same thing for the 4 little mounting holes. Then you're done. That's how long it takes. Now, if it's your first time using FreeCAD, it's going to take you a little while. But if you've been practicing for a couple of hours, that's how long it takes to do something. So you whip things out. So I'll just sidebar, just quick story here. You've all dealt with Zoom calls, right? You know, last couple of years. So I'm on those constantly. They make these little lights to illuminate you while you're on the call, so you have good lighting on you. And the thing has sort of a standard flash type base on them, you know, those quick base. So I was doing a call. I was actually in Washington. My wife and I were there for something. And I had to do a call there, and I have the light propped up on something. I'm like, darn it, I wish I had something that did this. And she looks at me and goes like, why don't you just 3D print one? I'm like, oh, that's rocket science. Why didn't I think of that? By the time, you know, after we taxied out and we're over 10,000 feet and I could use my laptop, in the next 15 minutes it was drawn. By the time I landed and we got home, I plugged it in, printed one, went, okay, I need to modify this, print another one. Next morning it was there, and there's a little thing that clips right on the top and holds the light. So it's those things. When you get used to the software, every time you think of something I need, just go and just draw it up and print it. So it's a cool thing to do that way. So electronics boxes, if you build any electronics things and you go to buy those boxes, those suckers are expensive now. They're like $15 or $20 to buy one of those boxes. And then you have to drill the holes for where things are going to go in, and the thing might crack. You know. Wait a minute, I know exactly the circuit board I'm putting in. I know where the holes are. I know how many connectors I'm putting in there. Draw it up, print it out, print up a cover, done. Yeah. Mm-hmm. Mm-hmm. Yeah, and as a matter of fact, the way I did this one, so it was easier for me to test the circuitry, if you look at where all the connectors on, it's on just a little plate. So I made the plate first that has all those bits on it, and then the box has a slot and 4 holes, so I could then just mount that on there. So I could test all of my connections all the way through on the bench and then just slide the thing in and put it on. I mean, you don't even need a template. All you need is a list of what the diameters are, and then when you go to just add the hole, you put it in at the right size. Okay. Yeah, so yeah, that's the easy way to do it. Yes, sir?
Why don't you print the labels? I notice you have stick-on labels. Why don't you print the labels in the box?
You could do that. Absolutely. You could have it just basically either do them as raised letters or engraved letters. Absolutely. I just didn't spend the time to do that, but you could do that. So that's another thing. Okay, what other things can you do where you can save oodles of money? Solar filters. Hint, hint, 2 eclipses coming up. You can buy the pre-mounted solar filters. They're expensive. They're $100+ dollars. I don't know if there's any that's under $109. But you can buy a couple of sheets of Beta film for $25 and punch out and use a big piece for a big thing and the smaller things for other bits and pieces. So there's a filter mount. That one's for a Star Blast, because my students wrecked the filter on one of those, so I had to make one up. And then I had bits left over, so you'll see here, I brought the filter from my 6-inch, actually my 6-inch that's up on the hill, and with a piece of the left over, I made ones for binoculars. So you just take your binoculars out and look at the sun with the leftover material. So that's all here for you to see. Yes, sir?
So how are you mounting the film to the
Okay, so the way I did this is, there are actually 2 pieces there. One is the outside piece, which fits over the tube, has a hole in it. And the second is a thin ring, which I think I made about 80 mils thick, same ID, and an OD that was 3 mils smaller than the big thing. And then you attach the film the way you normally do. You take pieces of double-sided tape, put them around that rim, drop it down, cut it off, and it slides in. And most of these the friction fit was good, so I left it there because it's trapped by the tube anyway. But if you wanted to, you could just put a couple of drops of super glue in there if you're really worried about it. So it just prints those 2 rings. I can only print 1 ring at a time given the size of my plate. So print one, print the second one, put it together, 20 minutes later, you're done. Yes, sir?
This is pretty good inside parts. Do you have a problem with container shipping? Because we've printed pretty good box and that kind of stuff. You know, like fit with ABS and the corners are kind of...
ABS is another story because ABS needs a heated environment and you have to be enclosed. There's a whole bunch of things with ABS. I have not shot ABS, in part because it's a nuisance to shoot ABS. And PETG seems to have the strength I need for most of the stuff that I do. But a lot of things, almost all my telescope stuff I do in PLA because the telescope's never going to get hot. It's in my observatory, it stays cold. So I don't worry about the heat, and it's cheap and easy and is really easy coming off the platen. Yes, sir?
Did you say FreeCAD did threads?
FreeCAD?
Does FreeCAD make threads?
FreeCAD does not do threads. But what I have found...
FreeCAD 2.0 does absolutely do threads.
Oh, 2.0 does now? Okay.
2.0 does.
Okay, so the new version does it. But I've also not had trouble actually tapping the stuff. I mean, certainly not where you're going to have a full strength that's supported by it, but things like lock screws for eyepieces, just take a tap, it works.
So you just bore the proper drill size.
Right.
And then tap it, it works fine.
Yeah, I've done that. But it's good to know from John that now you can't, that there are, I mean,
It's been in the last few months.
yeah, so now you have thread primitives and a completely free, runs on any platform CAD program. Mind-boggling. Yes, sir?
So, I don't use it, but I've heard that there's sometimes issues with the grain in the plastic you're going to make because of the constant layering.
Mm-hmm. I haven't found that to be an issue on anything that I've made so far.
About like a grain, if you
But,
lay it this way, this is that way, what's the question?
well, the question is, because it lays down layers, so imagine if you're making a disk, it's going to run this way, then it's going to run that way, then it's going to run this way, and then it's going to run that way. So it's not a completely like uniform. It's not like a Zamboni putting new ice down, okay? So there are fundamentally grain issues. You have things in different planes. So this is getting beyond what I want to talk to here, but for example, you can change layer thicknesses. So if you were making something thin and you were concerned about that, you could put in thinner layers to have more. Yeah, I mean, there would be ways to deal with it, but that's beyond where we're going here. So as I mentioned with this, I made the caps for binoculars because I had the bits left over. I'm like, that'll fit, and we'll do that. So I have those here for you to see. And so there you go, solar filter on there, lens cap, all those parts 3D printed and do well. Then you can make some other things to solve other annoying problems. I find it absolutely annoying to have to kind of cover my head looking through an H-alpha scope, so you make a solar screen. And that puts the shade on there. And I just made a clamp that fits around the tube so I could hook anything I wanted on there. So I've made one for every one of my telescopes that I do for solar. So you can put a screen on there, you can hook anything on there, you just know the ID for the tube, print one out, bingo, done. Now, here's the thing. Now that I've made all those, I've had a better idea. And the better idea is where I have a bolt and a wing nut to hold it on, I should have slotted that so it's easier to put on and off. It's like, okay, one of these days when I have 15 minutes on a rainy day, I'll add slots to the thing and reprint them, right? Not that these are bad, but that would be better. And there's one of the solar finders there. Big binoculars due up. Dew shields. Those are 16 by 70s. Easy to make dew shields on there. Okay, so the primary goals of what I'm talking about today, beyond the ability to customize things and do fancy things and do big things, is to make ATMing easier and more economical. Because I think that's a barrier to getting people to make instruments and to be connected to things the way that we want it to be. Add the diversity of telescope makers. There are whole populations that won't get into this just because of the expense involved. And the fact is now that kids in school love tinkering with things. 3D printers, every school's got 3D printing. Kids love doing this stuff. Maybe you get into this by making those things first and then you want to add optics to it to do stuff. I accidentally clicked that. Let's go back for a second. And yeah, get younger folks involved in this. I have no question that 3D printing existed 15 years ago when I started doing these things on campus. We would have had kids making all sorts of parts and coming up with new ideas and doing things, which would have been great. Oops, darn it. The delay on that thing drives me nuts. So opportunities, you can customize everything like the base on a focuser. You decide to put in a new tube, you print a new base, you put it on there, right? You can get your secondary, the offset just perfectly. You can make your mirror clip just the right length. I can build the offset angle on my sheaf spiegler right into the part as opposed to having to tinker it in with nuts and bolts and screws. You can experiment at low cost. I wonder if this will work. I'll make one. Oh, well, that doesn't work. Okay, chuck it, go on to something else. By the way, most of the plastics here are recyclable, so they go in your recycle bin. And it's like, okay, that didn't work the way I wanted. That's okay, I can experiment. And it's a great way to invent and innovate. I mean, I think I've come up with a couple of cool gizmos, like a little flip thing to keep my finder from eyepiece from doing up. I mean, that wouldn't have come about if I was going to have to make a very complicated part where it's like, I'll try this. If it works, fine. If it doesn't work, okay. So I think there's opportunities to invent a lot. So that's contact information for me. Please do check out the outreach program that I run, Mountains of Stars. We have tremendous amounts of resources and information. Some of you were at Hartness House yesterday. I spoke there. But please take advantage of that stuff. So I'll answer more questions and then please come up because most of this session I want you to be looking at parts and seeing how we do things and coming up with ideas to do stuff. Yes, sir. Well, I mean, compared to a machined aluminum part, obviously it's not going to be as durable. But it also depends on the use. Like a secondary mirror holder, that thing is, I mean, it's never going to die. I mean, once it's in there and it's working and it's lined up, what's going to hurt it? You know, I don't have to have a big chunk of aluminum that cost me $35 for the bar stock from McMaster Car. I printed that thing out for 75 cents. It's going to be in there forever. Now, there are going to be other parts which are moving parts or something, which will wear out. So you know what you do? You print another one. I mean, that's one of the nice things about it. But you know, you're right. I mean, there's no question a moonlight focuser is going to last a lot longer than a 3D printed thing. So $400 versus $1.50, right? And it depends where you are and what you're doing. If you're going to put a big CCD camera on there, buy the moonlight or machine one up like I do. by all means do that. But if you're like, I'm just going to be looking at stuff, this will do you just fine. Yeah, let's work left to right.
Can you spend a minute talking about the different types of 3D printers?
There are a whole variety of different kinds of 3D printing technologies. The dominant one is what we're working with here, where you have a transverse table, a running head that can move up and down that basically squirts bits of plastic or plastic material. There are some other technologies, but this is by far the economical one that we all use.
Second part is, if you wanted to get rid of the vertical grain, what would you recommend? Sand, 400 with water, or what?
To get rid of,
The grain?
you can certainly lap parts together if you want a really tight fit. In fact, I spent a chunk of time on these. Again, because you can prototype, you print a bunch of things and you go, has a little too much play, and you don't have to print the whole thing. You print a little piece of, let's make it 2 mils bigger, let's make it 5 mils bigger, let's make it 7 mils bigger, and figure out which one does what I want. But then you could make it a little stiff and then run some 20 mic and water, run it back and forth a few times. You'd probably make a super duper setup.
You go back to the contact info, please.
There you go. Matt? Yeah. Yeah, McMaster Car, if you go to, there is the STL file, the file you need for every single product in that catalog. So you can just take it down and make the part without buying it at all, which is absolutely mind-boggling. Yes, sir?
To chime in on the grain question, if you have a thermo-resilient plastic like PETG, you can just run a hair dryer over it and it'll start to melt the layers together.
Yeah. Good to see you.
Yeah, good to see you.
Glad that you're here. Wow, we'll have to catch up. Yes, sir?
Getting back to materials, wouldn't the durability of the part that was produced depend upon the type of material?
Yes, of course.
You mentioned carbon fiber.
Right.
That would be more durable than something else.
Right.
And it would hold up a lot longer.
Yeah, absolutely. And then it's a matter of an incremental investment because that reel is going to be more expensive material, but still you get so many parts out of it. It's like if I were making, it's the same thing you do with other things. If I'm going to make one part of this, post a note of something. Does anybody have a couple of feet of this stuff that I can just go use and buy some because you don't have to buy, a whole kilo of it. But if you're going to be making a bunch of parts, certainly you could invest in that technology. Or something else, yeah. As I said, almost everything I've done is dominated by either PLA or PETG. So like the solar filter stuff, because that's going to be sitting in the sun, is PETG. And it's structurally, nominally sounder than doing stuff in PLA. But for most of the stuff, PLA does what I need. But between PLA and PETG, both of them are about $28 a kilo. And a kilo goes a long way. Yes, sir.
How much more expensive is the metal infused?
That I don't know. John, hey, how much is like a kilo of the metal-loaded stuff? Do you know? The copper or the stainless?
Typically 23 to 25.
It's all about the same.
The carbon stuff runs a little more, and it does tend to get sticky and clog the nozzle. So it's a little more challenging to print, but $30 will buy you a kilo.
Yep. So it gives you $30 a kilo. And by the way, John and I have had some things because he saw one of these focusers when we were up here this winter. He said, "Hey, I want to try with that. What did it take?" I sent him an email with the file, and he went tinkering with it and did stuff. And that's the beauty of all of this. Yes, sir.
How do you deal with the absorption of moisture, particularly in PLA, on your reels? We take our reels off and put them in a box with a heater in it.
Huh. I haven't really had an issue. I think my home is probably just dry enough that it just hasn't been an issue. But yeah, it's also a matter of how quickly you burn through stuff. Yeah, so if you're making stuff, that's good. In the back, and then you, sir. Yeah. Could you come up or something? Because I can't hear you, and if I can't, they can't.
I have a multi-part question. First one is, do you have any experience with any like plugins for FreeCAD that might be particularly beneficial? Like I know you mentioned threading earlier. I was wondering until the gentleman over there said it was available 2.0. It was like the threading plugin. And then the second question I had was, have you experimented with any mods for your 3D printer, like putting a cement block under it for rigidity? And then the last question, part of the question, is what can you speak to the precision of the produced parts?
Okay, so to quickly answer yourself, I have had good luck with between FreeCAD and Fusion 360 to do everything I want to do. And you can export formats and go back and forth between them. And so I will sometimes draw something in one because it has features that makes it easier to do. So for example, it's really easy to fillet and chamfer in Fusion 360. That's a little harder to do in FreeCAD. I'm not even going to worry about getting it into FreeCAD. I draw the part, then I just bring it into Fusion. I go fillet this, fillet that, boom, okay, that's done. So I find it easy enough to do that. And the fact that Fusion had all the threading in it, I ended up doing a lot of stuff in Fusion just because it would do that for me, or I'll move a part back and forth. Meanwhile, a lot of the Boolean operations and some of the other things are easier to do in FreeCAD, so sometimes it's easier to start in one and go into the other there. As far as mods to the printing, no, I built my Prusa, put it on my workbench, and it hasn't moved. And I haven't found anything really serious to deal with on that, so that covers it.
What about the precision of the parts?
The material does make a little difference. So for example, if you're making the focusers and you want a smooth but play-free thing, that's where prototyping helps. Like just print a section and see how it's going, and you may have to adapt it a little bit if you change material or you change printer. So if you take my STL file and you're not printing on a Prusa 3 with my material and you're producing it on something else, you may find it's not exactly the same, but the precision as a whole is unbelievably good. Like, I just used the printed dimensions for where the holes were on that motor. I printed it, put it over, and the screws went right in. So it was certainly within a couple of thousandths. That's pretty killer. Yeah, pretty killer.
And for the measurement, do you take any measurements or anything using
Mm-hmm.
your
Yeah, I'll mic things out if I'm trying to make something that's a precision fit.
like with the telescope, you make like any kind of measurements or anything like that, like any data or anything like do you collect any data for your scopes
Well, I mean, the scopes that I make for myself in my observatory, I use for either looking at stuff or I'm doing video broadcasts to schools that I work with. My research stuff, I get big class time, and I do that. Yeah, that's what I need. Yes, sir.
My question is about safety. Well, I'm thinking of this in my house and melting, not melting, fumes and stuff like that. Do you have any concern about that?
There are certain plastics like ABS you do have to worry about when you're shooting ABS. PLA, I'm not aware of any significant issues. When I first got it and was running it, my real concern was that my cats would say, "Ooh, look at this," because it has little moving things and wires, and Ty and River like anything that moves and has wires. So I kind of closed off that part of the basement when I was, but now it's clear they don't really care, so I leave it alone. But if you had an inquisitive dog in your house or something, I would think about putting it someplace, or building a little, get some 1x1 at Lowe's and build a little box with some screening and put it over there just so hands don't get on it. That's not much to do. But yeah, I mean, it's not unreasonable things with moving parts and fingers and little kids and pets can be an issue. ABS is the only place where you really run, of common materials, ABS, PETG, PLA, I think ABS would be an issue.
PLA is actually cornstarch.
Yeah.
So it has essentially no fumes that I've ever witnessed.
Right, no, you don't even notice it's running.